Okay, let's see now question number 5. Question number 5 is sine raised to 2 upon 5 of log x. So I will write y equals to sine raised to 2 upon 5 log of x. So this is my y. The next step I write as sine of log x the whole raised to 2 upon 5. Okay, once again, this I wrote because this is the first problem of its kind. Later, we will not need such kind of simplification because we will be understanding all such kind of functions very well. But this being the first question of its kind, I am writing it as sine of log x the whole raised to 2 upon 5. Here I have written an explanation for this. See students, when you have sine square theta, you all know the way of writing it as sine square theta, but what it means is sine theta multiplied to sine theta, which is sine theta the whole square. So the same way, when I have the power of sine as 2 raised to 5 and the variable is log of x, so though we write it this way, but actually what we mean is sine of log x the whole raised to 2 upon 5. So once again, what is the step here? The step is I need to recognize what kind of function is this. So here I am writing differentiating both sides with both the sides with respect to x. So d by dx of left hand side, which is y, d by dx of y, and d by dx of sine of log x the whole raised to 2 upon 5. And here I have to recognize the function in order to recognize the function in order to apply the proper result. So this is sine of log x the whole raised to 2 upon 5. I want you all to pause the video here and give the answer on your own. I want you all to pause the video, please. What kind of function is this? Sine of log x the whole raised to 2 upon 5. See, you find log function, you also see sine function, but never say this to be a log function. Do not call this to be a sine function. Why? Look at this power 2 upon 5. So the outer function is the main function here is wherein we will apply the result is variable raised to constant. What I want you all to understand is this part becomes the variable. See, this base is variable. First of all, this is variable and then power is constant. So outer function decides the result to be applied. It is variable raised to constant. Definitely later in the solution, sine will come, sine will play its part, log will also come, log will play its part, but in the beginning it is what kind of function? It is variable raised to constant. So variable raised to constant, but the variable is not x. The variable is not x. You are differentiating with respect to x, but is this x raised to 2 upon 5? No. What it is? It is f of x raised to 2 upon 5. So if I ask you what is d by dx of x raised to n, you know d by dx of x raised to n is n into x raised to n minus 1. D by dx of x raised to n is n into x raised to n minus 1. But do we have x here? No, it is f of x. So its derivative will be d by dx of f of x raised to n will be n into this will be f of x raised to n minus 1 into d by dx of f of x as usual. So here you will apply that result d by dx of x raised to n, d by dx of f of x raised to n. So it will be 2 upon 5 sine of log x raised to 2 upon 5 minus 1 sine of log x raised to 2 upon 5 minus 1 into d by dx of sine of log x. Why? Why d by dx of sine of log x? Because you have to multiply d by dx of f of x, and f of x is sine of log x. Then next step, you have 2 upon 5 sine of log x, and you will do the simplification here. This will get you minus 3 upon 5 d by dx of sine of log x you have to write. Now here comes, once again I ask you, what is this function whose derivative you are required to write? It is sine function, but this is not sine of x. Once again, sine function, but it is sine of f of x. D by dx of sine of f of x is cos f of x into d by dx of f of x. the f of x here is log x. So cos log x d by dx of log x. And then this part you simplified the power became minus 3 upon 5, and this whole thing is copied as it is, and cos of log x is as it is, and d by dx of log x is 1 upon x. The final step is the uh, the sign of log x raised to minus 3 upon 5. This is written in the denominator, so the power will become positive, cos log x, and x, this x is written here. So the final answer is 2 upon 5, 2 upon 2 cos log x, 2 cos log x upon 5x into sine raised to 3 upon 5 log x. This is the end of question number 5. Now we go to question number 6. Question number 6 is question number 6 is cos root of cos x plus root of cos of root x. Root of cos x plus root of cos of root x. What I will do is I will write this as y. So y equals to the RHS. Then I write differentiating both sides with respect to x. Okay, now here what I notice the RHS which I need to differentiate is sum of two functions. Look at this plus sign. It is sum of two functions. So the first step is I will write d by dx of root cos x plus as it is, and d by dx of root of cos of root x, this thing. Then I go ahead. What is it? I apply d by dx of root of cos x. This is d by dx root function, square root functions. So d by dx of root f of x. What is d by dx of root f of x? 1 upon 2 root f of x into d by dx of f of x, and f of x here is cos x, plus once again same function, it is square root function. It is d by dx of root of f of x. See, this is f of x. This time f of x is this. You can just check here. You know, d by dx of root f of x. F of x was cos x, but here f of x is cos of root x. So 1 upon, now derivative of this, derivative of this is this thing here. You know, here I have written derivative. So d by dx of root of cos root x is 1 upon 2 root of cos root x into d by dx of f of x, and f of x is cos of root x. The next step. Now the next step, this part is copied as it is, and d by dx of cos x is minus sin x. This part is copied as it is, no change required in this. Okay, look at this part. D by dx of cos of root x. It is d by dx of cos root x. Which function you are differentiating? You are differentiating cos function, but it is not cos of x. It is cos of f of x. It is not x, it is root x, which is now f of x. So cos f of x will be minus sin f of x into d by dx of f of x. So derivative is minus sine root x into d by dx of root x. And then next step, this is simplified. Minus sine x into 1 is minus sine x upon 2 root cos x, denominator as it is. And here minus sine of root x into 1 is numerator, here minus sine of root x, the denominator is as it is, and d by dx of root x. What function is this? This function is square root function. And finally what you notice, that it is the variable is same as this, so it is your main result by definition. So d by dx of root of x is 1 upon 2 root of x, and this gets you the final answer. Negative multiplied with negative will become positive. I'm sorry, I missed it. This is not multiplication, I'm sorry, this is plus sign here. So minus sine x upon 2 root cos x as it is, and this negative multiplied with positive is negative, and the rest of thing, this 2 multiplied with this 2, and you get 4 here, and this is your answer. This is the answer for question number 6.